Okay, in this video we're going to take a look at the lab we did in class on chapters 2.1 through 2.4. This is going to be a video using RStudio. So just to refresh you, we do have this instruction sheet which you have to turn into Blackboard. And anytime there's a highlighted yellow mark, you need to put an answer. Anytime there's a highlighted blue mark, you have to insert a picture, whether you capture it or use the snipping tool, whatever means you want to. So the first thing it asked us was, what is the explanatory variable x? So here we decided it was going to be body weight, and the response variable was going to be backpack. So I'm going to call my body weight x and my backpack weight y. And we're going to go ahead and put these into R as a list. Again, we'll call it x, and we'll go ahead and put those weights in. Okay, go ahead and enter those in. And then next we'll put in our y for backpack weight. Okay, we'll go ahead and enter those in and take a look at those values. Okay, next thing it asked us was, what was the mean of the body weight? So yeah, I'll just put some comments in here. This is body weight. This is the explanatory variable. And y was the backpack weight. The response variable. That's sufficient. Okay, so next thing we want to know is the mean of body weight. So let's call this x bar. That's going to be the mean of x. Okay, so we get 136.125. And then it asks us what the mean of backpack weight is. Call this y bar. And that's going to be the mean of y. Okay, 28.625. Now it says, what is the sample standard deviation of body weight? So I will call this S sub x. That'll be SD of x. Okay, so we see that's 30.29586. Then we want the standard deviation of backpack weight. And we'll call this S sub y. That'll be the standard deviation of y. That's 3.461523. Then it wants to know, what is the correlation coefficient of R? we'll just call that R, and that'll be COR of X comma Y. That'd be 0.794697. So this is positive. So we know we have a positive relationship, and it's pretty strong. I mean, it's as closer it gets to 1, the stronger it would be. That'd be a perfect positive relationship. So 0.79, about 0.8, that's pretty strong positive relationship. All right, next one wants us to calculate the slope of the best fit line using, well, let's go ahead, slope, up here. Slope of best fit. Again, we're using the least squares regression line, where A, or Y hat, is going to equal AX plus B, where A is equal to the slope, which is equal to R times SY divided by SX. Okay. So A, we'll call this A. That's going to be equal to R times SY divided by SX. Okay. So you can say our slope is about 0.09. Okay, now we want to find the y-intercept of the best fit line. So B is equal to y bar minus x times, we'll call A times x bar, where A is the slope we just found. So B is going to be y bar minus A times x bar. Okay, so that's about 16.26. So, all right, we have our slope and our intercept for our least squares regression line. Let's see what it asks us to do next. So now it wants us to use this y-hat equation to find the predicted value of a backpack weight when the body weight equals 140. So find predicted y when x equals 140. So I'll go ahead and call my, I'll call it y 140, and that's going to equal A times 140 plus B. Okay, so about 28.976. Now it wants to find the predicted values of y hat for the given body weights. Okay, so we have our, let's just look at it again. We have our x values, and we want to go ahead and predict our backpack weights from those. So I'll go ahead and say actual, which is going to equal y. Okay, and then I'll say predicted, which is going to equal A times X plus B. So remember that R does vector arithmetic. So if I send a vector into this equation, I'm going to get out as a vector, and each of those are going to be the predicted values with the corresponding X. Let's see what that looks like. Okay, so those are my predicted values. And again, I have my actual values right here. So if I were to look for the residuals, or the error, it's going to be the actual minus the predicted. So it did want you to use the snipping tool and paste the predicted values here. And then after that, we're going to paste the residuals. So let's call the residuals RES. And we're going to say that is going to be actual minus predicted. And if you look at that, okay, notice that our first 4 values are negative and our second 4 values are positive. Okay, so again, you're going to want to copy and paste those residuals, a snippet of it, and paste it into your answer key. All right. Now I'm going to start taking a look at some of these plots. So the first thing we want to do is we want to set our plotting up to do 2 on one page. So we're going to use the par MF row equals, we'll do concatenation of 1 and 2. That should be 1 row, 2 columns. All right. Now, I want to make a scatter plot of the data points. Now, I will note you could just do plot x comma y and get a basic scatter plot. Let me zoom in a little bit. But I want to make it look pretty. So, I'll do this again. Oops. So I'm going to copy and paste this from the instructions. Okay. So to show you what I have here, I have plot x and y. I want to add my title, which is actually going to be backpack weight versus body weight. And then I'm going to make it red. My printing character, I'm going to use number 2, just a triangle. CX is going to change the size of my printing character. I'm going to label my X and Y axis, body weight, and backpack weight. All right, there we go. All right, so let's see if I can enter this whole line. Let me select that. Okay. So again, we see my little printing characters. The next thing it wants us to do is add the predicted point. All right, so here, let me close this. We can use the points command. Let me get this so you can see it all on one page. Okay. So the points command is going to automatically add to the graph. You don't have to put add equals true. And we're going to put the point 140. And we call it Y140. We'll do color equals purple. And we'll use printing character 7 this time. And for the printer character size, we'll do 5. Okay, so you can see there's our predicted point, the little box with X through it. I mean, it's definitely in the area. So now we're going to add the best fit line to this curve. So here we're going to type in the curve command, which again, this time we'll have to do add equals true, but we'll use our equation over line. So A times X plus B, and we'll do add equals true. Right. There, I'll zoom in here again. So you can see there's our best fit line. Notice that our predicted point is on the best fit line. All right, the next thing we want to do is we want to go ahead and plot the residuals. So to do that, we won't get fancy with it. We'll just do plot res. Okay, so you see your residuals. And then we want to add the horizontal line at 0. So the AB line command will again automatically add to the graph. So the plot, we'll do H equals 0. And let's give it a little color. We'll do color equals red. And LWD width equals 3. Okay, so you can tell here, you got a few points below, a few points below. We already saw it was 4 below, 4 above, but it doesn't seem to be any necessarily pattern to it. So it's looking pretty good. We're going to go ahead and paste a picture of both these graphs. Now you want to take a look at calculating SSR and SST, so the sum of square residuals. So here, let's just do SSR. So this is going to take the difference between the predicted value and the actual value, and then we're going to square that for each point, and then we're going to add them all up. So we'll call it the sum of residual squared. So let's take a look at that number. Ooh. SSR. There we go, about 30.9. And we want to find the sum squared totals, which is, this was the difference between the data point and the mean, and then we'll go ahead and square that, and we'll add all those up. So that's going to be the sum, and we do the difference between y minus y bar, and again we're going to square that. I guess we do this here. There we go. Sum all that up. And let's take a look at that. That's our 83.875. All right. So the last thing, we want to go ahead and calculate R squared. Let's put it like this. And remember, that's 1 minus, equals 1 minus, and then we're going to do SSR divided by SST. So again, the closest to 1 this number is, the stronger it is. So we'll call this R squared, and that's going to equal 1 minus SSR divided by SST. Okay, so let's take a look at R squared. 0.6315. Notice this is actually, if I did R times R, you get the same thing, right? So R squared is the coefficient of determination, and R is the coefficient of correlation. Remember, R is between -1 and +1, and the absolute value of R is the strength, so between 0 and 1. And here, the closer R gets to 1, the better the model fits the data. All right, so we went through a lot of calculations, and there is an easier way to get this stuff. So what I'd like to show you now, just real quick, we can use the linear model function in R and get all the information pretty fast. So here's how you could do it. So here's an alternate way, which is a lot simpler. So we could do, call it fit, and that's going to be the linear model of Y predicted by X. Okay, and if I do a summary of fit, oops, I get a bunch of information here. Let me scroll up. So things I'm really interested in right now are the coefficient intercepts, which is B, and then our slope, which is X. So notice this matches up with what we calculated. The other thing I want to show is that the R squared, and this is exactly what we calculated as well. So you can pick off those coefficients. For example, if you did, you don't have to, right? You can just write those down. But if you did coefficient equals coef of fit, look what we get here. So co, that's my intercept and slope. So we'll just call it A1, so we don't get confused with the other A value we have. I could say this is CO into C2. Okay, so you notice now we've picked off the slope. I could say B1 is CO into C1. And notice here, we've now picked off the intercept, so we can access that. All right, a little sidebar. Now, back to what I was getting. So we could just go ahead and plot or actually, before we do that, let's go ahead and plot the data. So plot x comma y. We won't do anything fancy this time. Okay, those are our points. But now we can actually do an AB line to get our best fit line in here. And again, we're going to use the AB line, but we're going to use a linear model of y predicted by x. Okay. Let's add some color to it though. Color equals red. And we'll do width equals 2. Alright. Oh, supposed to be a comma there. There we go. So there's my least square regression line. Same thing we just did. If you want to take a look at residuals, call it res1. This is actually a resid command, a function. Residuals of fit. Okay, if I take a look at those, we should see that those are exactly the residuals we found earlier. And of course, I could plot the residuals, res1. Okay, I can add the AB line. Again, h equals 0. Color red, and we'll do the thickness equal to 2. All right, there you go. So R has a lot of built-in functions that will help you loop these linear models and least square regression lines, pick off the R squared, pick off the slope and the intercept pretty easily. So hopefully you found this helpful, and stay tuned for the next video.